Hello students, the next concept is the electromagnetic induction. Okay, what is the electromagnetic inductions? I think might you have not heard this word electromagnetic inductions. Now you will become familiar to the electromagnetic conditions. Is it okay? Now let us start the concept of the electromagnetic induction. First of all, we will try to learn these electromagnetic inductions by doing some of the activities. We are going to perform the two activities, and from the two activities we will understand the electromagnetic induction, and then we will come to the statement of the electromagnetic induction. Before proceeding to this electromagnetic inductions, let me introduce one another instrument. Clear? That is what called the galvanometer. What is the instrument? Called as the galvanometer. What is the galvanometer? It is a device used to measure the amount of current present in the circuit. Instead of that, we can say galvanometer is used to show whether the current is present in the circuit or not. For what purpose we are using? If suppose we wanted to know in that circuit whether the current is present or not. If suppose there is a small amount of the current is present in that circuit and that current can be detected, the instrument will tell us whether the current is present or not in that circuit, and that instrument is called as what? The galvanometer. This galvanometer actually, it doesn't show any type of what we can say the particular readings, but it will just deflect degree. It will just deflate. And this galvanometer is look like this. Is what the symbol of the galvanometer, G. Clear? And when we focus on this galvanometer, actually what happens? The galvanometer has a null point. What is the null point? At the center of this galvanometer, 0 is mentioned, and the pointer of this galvanometer initially toward the 0. Initially at the 0, and when this position is there, which is called as the null point. Clear? Now as soon as when we connect this circuit, when we connect this galvanometer in a circuit, and if galvanometer, this pointer deflects from its 0 value, when it changes from its 0 value, which means that the current is present, either it will deflect to the left or to the right, which means that there is some amount of current is present. So when we can say the current is present in the circuit, which means that when the galvanometer shows the deflection after connecting to the circuit. Clear? So this type of device is called as the galvanometer. It tells us whether the electric current present in the circuit or not, because we are going to use it extensively to understand the electromagnetic induction. Is it clear? Now come to the concept of the electromagnetic induction. As you can able to see, this is what the picture over here. Let us do this. Let us learn this electromagnetic inductions by doing some of the activities over here. What activity I am just going to take? Now let us have a solenoid. Clear? And this is what now? Galvanometer. Getting what I am saying? Initially the pointer is where? Exactly it lies toward the 0. Remember that. This is what the position. Actually there is no current now. Now what happens here? I have taken one magnet, and this magnet, this is the north and this one is what? The south. Now what I am trying to do, you know that? This magnet I am trying to bring close to the solenoid. Clear? Now as I am bringing this magnet close to the solenoid, it was observed that this galvanometer has shown a deflection. As in that it shows a deflection toward the right. Did you know what I am saying? As soon as I was bringing this magnet, as I brought this magnet close to the solenoid, galvanometer was showing the deflection. But right now what we have discussed about the galvanometer, when the galvanometer shows the deflection, which indicate that the current is present in the circuit, this is what it happens. As soon as we are trying to draw the magnet close to the solenoid, galvanometer showing the deflection, which means what? The current is produced. We have not connected this solenoid to the any batteries, but still this galvanometer showing the deflection, which means that whenever there is a relative motion between the solenoid or the coil and the magnet, then inside a coil, current will induce. What will induce? Current will induce. Similarly, if suppose you are, now this is the north pole we brought close to the solenoid. Now instead of that we just bring south. So what will happen? The galvanometer might show in this or the opposite side of the deflection. That's it. It will show the deflection toward the other side. This is what the concept. Now what will happen if suppose we are taking this magnet away from this solenoid? What will happen if suppose we are taking this magnet away from the solenoid? Then it was observed that the galvanometer was showing the deflection in the opposite direction. Clear? And if suppose I will take this magnet and place this magnet inside the solenoid, so then the galvanometer will not show any deflection at all. Will it show? No, the galvanometer will not show any deflection when we place this magnet exactly at the center of the solenoid. And if there is no position, galvanometer is also solenoid is also at rest and the magnet is at rest. Will it show deflection? No. When it will show the deflection? When somehow amongst these two, if anyone is in motion, galvanometer will show the deflection. अब हमने इस दो केस में क्या किया कि हमने मैग्नेट को मूव किया. अब हम क्या करें कि मैग्नेट को वहीं पर रखेंगे. अब मैग्नेट को वहीं पर रखेंगे, इसका मतलब क्या है कि मैं किसको मूव करने वाला हूं? कॉइल को मूव करेंगे, सोलेनॉइड को मूव करेंगे. तो क्या होगा? When we move the coil toward the magnet, it was observed that galvanometer was showing the deflection. That is what it is called as the electromagnetic induction. ये क्या हो रहा है? This is what the coil. Getting what I am saying? This is the coil, and when this magnet is brought closer, galvanometer was showing the deflection. Why? As we are bringing this magnet close to the coil, then the magnetic flux through this coil is what increases. When the magnetic flux through the coil is increases, it shows the this change in magnetic flux. क्योंकि हम जैसे जैसे ला रहे हैं इधर, उसके थ्रू की magnetic flux क्या हो रही है? Change हो रही है. Magnetic field lines are traveling more and more, and due to because of this change in magnetic flux or magnetic field, it produces a current inside this coil, and that coil is called as that current is called as the induced current. Which current? Induced current. From this also we can easily understood. Clear? Okay. Let us do another activity also. Now, this is what? There is no magnet, nothing is there. Let us suppose this is what the positive and let us suppose this is what the negative. So, current will start flowing from positive to what? Negative, and this will the current will return to the negative terminal. Now here galvanometer is connected, and these two coils are placed like that. Clear? To one coil, battery is connected, and to the other coil, galvanometer is connected. Now what happens? As soon as when this coil, that the current is flowing through that solenoid. Now as soon as when we brought this solenoid close to that one, or when we change this solenoid toward this coil, let us suppose this coil is the primary coil, that is C1, S1, this one is called as what? S2. As we take S1 toward the S2, so what happens? You know that this galvanometer was showing the deflection. क्या हो रहा है? क्योंकि because of the flowing current, magnetic field generated in that coil. Now as we are bringing this S1 towards S2, the magnetic field through this or magnetic flux through the S2 goes on, changes, which produces the current called as induced current and shown by what? Detected by the galvanometer. Clear? So from these two activities, what we have learned? We learned that change in magnetic field produces electric current called induced current, and the phenomena is called as electromagnetic induction. What it is called as? Electromagnetic induction. Is it clear dear? So this is what, अगर आप देख रहे हो यहाँ मोशन कौन सी डायरेक्शन में, इधर तो डिफ्लेक्शन उधर है, और इस डायरेक्शन में मोशन उधर है तो डिफ्लेक्शन इधर है. तो क्या हो रहा है? अपोज कर रहा है. That's it. Clear? You will understand at the higher standard, but this is what the exactly concept it is to be called as electromagnetic induction. Change in magnetic field produces electric current. That electric current is called as the induced current, and this phenomena is called as the electromagnetic induction. Clear? Very good. Now, this electromagnetic induction is very important. For what purpose this electromagnetic induction is very important? Just to understand the concept of what it is to be called as some of the devices. There we are going to be finding out. Now, if suppose we wanted to calculate the direction of the induced current. So, for that purpose, we are having another rule given by the Fleming'S, that is called as the Fleming'S right hand rule. What is Fleming'S right hand rule? What is the Fleming'S right hand rule? This is what? This is what the Fleming'S right hand rule. This is the force. This one is the magnetic field, and this one is what? Induced current. Outstretched thumb gives the direction of what? Force or the motion. This forefinger gives the direction of what? Exactly magnetic field, and the middle finger gives the direction of the induced current. See dear, these are the two rules are there. This is called as the left hand rule, and this is called as the right hand rule. In case of the left hand rule, it is used to find out the direction of motion or direction of force, and right hand rule is used to find out the direction of what? Induced current. Getting what I am saying? This is a very important here. So according to the Fleming'S right hand rule, what is that? Thumb Thumb indicates the direction of force or what motion. Clear? And forefinger or index finger indicates the direction of what? Come on, magnetic field. Clear? And middle finger gives the direction of induced current. Remember that. What is the difference between the FRHR and FLHR? I will tell you, correct? So then what we know in the Fleming's left hand rule, we know the direction of force, we know the direction of magnetic field, we don't know the direction of induced current. That we wanted to be find out. Needs to be found. Clear? Need to be found. This is what the concept it is to be called as. अगर आप थोड़ा सा इसमें ए करोगे तो आपको बहुत जल्दी समझ में आएगा क्या FLHR और FRHR क्या है? करंट, दूसरा फोर्स, तीसरा मैग्नेटिक फील्ड. IFB. What are the things we know in FLHR? We know the direction of electric current. We know the direction of what? Magnetic field. We don't know the direction of force. That needs to be calculated. Okay. Similar in FRHR. We know the F and we know the B. We don't know the I. This is what to be find out. To be find. There also. This is what? To be find. This is the current. To be find. But this is what? Which current? Induced current. Now what is the definition of the induced current? The current which is produced due to because of the change in magnetic flux is what it is called as the induced current. Clear? Induced current का मतलब क्या है? क्योंकि हमने मैग्नेटिक फील्ड वहां पर चेंज की, उसकी वजह से जो करंट उस कॉइल में बन रहा है वो कहां से होगा? That called as the induced current. Is it clear? And this is what the electromagnetic induction as well as the Fleming's right hand rule. Get what I'm saying? Here we are going to use the two cases. One is called the electric motor and electric generator. In electric motor, we are going to take the help of what the Fleming's left hand rule, and in electric generator, we will discuss about the Fleming's right hand rule. क्योंकि इलेक्ट्रिक मोटर में हमें करंट का डायरेक्शन पता है और डायरेक्शन ऑफ मैग्नेटिक फील्ड पता है, लेकिन डायरेक्शन ऑफ फोर्स पता नहीं है. सिमिलरली इन केस ऑफ द इलेक्ट्रिक जनरेटर हमें किसका पता है? डायरेक्शन ऑफ फोर्स पता है, डायरेक्शन ऑफ magnetic field पता है. We wanted to calculate the direction of induced current. This is what exactly it is all about the electromagnetic as well as Fleming's left hand.